In this section, we will quickly learn the derivatives and integration of inverse hyperbolic functions or functions involving inverse hyperbolic functions. To find derivative of inverse hyperbolic functions, first write its logarithm equivalent form, then apply the usual derivative. So here our derivative of hyperbolic sine inverse is just the derivative of this quantity ln x plus x square plus 1 square root. See, we know how to find its derivative. We will apply the usual procedure. Here we have to apply the chain rule. Ln is our outer function, so its derivative becomes 1 over the inner part is x plus x square plus 1 square root, then the derivative of inner part x plus x square plus 1 square root. What is this one? This is same, x square plus 1 square root. Derivative of this one is 1 plus, what is this one? This one is x square plus 1 to the power 1 over 2. So again chain rule, 1 over 2 comes outside, x square plus 1 to the power 1 over 2 minus 1, which is minus 1 over 2. Then we have to multiply that one with this one with the derivative of x square plus 1, which is 2x plus 0. This one is multiplied this quantity. So what we have, this is 1 over x plus x square plus 1 square root, then 2 gets cancelled, so we have 1 plus x over x square plus 1 square root. What do we have? This is just x square plus 1 square root plus x divided by x square plus 1. 1 plus 1 over x plus x square plus 1 square root, and these two cancel, so we have 1 over x square plus 1. This is square root. So this is our derivative of inverse hyperbolic sine. And similarly, you can find the derivative of all other inverse hyperbolic functions. Here I have listed all derivatives and integration rules of inverse hyperbolic functions. We have proved this one, the derivative of hyperbolic sine inverse. In the similar way, you can prove the derivative of all other inverse hyperbolic functions. You only have to take the logarithmic equivalent form, then proceed with the usual differentiation rules, the chain rule and all other things. Integration is just the reverse process of derivative. If the derivative of hyperbolic cosine inverse is this one, then integration of this one is inverse cosine function plus c. C is any arbitrary constant. You may take a note of all these things. Next, we will do just one question involving inverse hyperbolic function. Let it be integration. Let us evaluate integration of dx over 4x square minus 9 square root. This integration is in this form, where you have some constants here only, 4 and 9. So we have the integration of 1 over x square minus 1 square root is cosine hyperbolic inverse x plus arbitrary constant. Now let's divide the denominator by 9. What I am saying is we have dx in square root. Let us divide it by 9. If we divide, then you have to multiply 9 here. See, so this becomes 4 over 9x square minus 1 square root. Let's take this 9 outside. When 9 comes outside of the square root, you have 3 here. So 3 is a constant. You can take 1 over 3 outside of the integration. Now let's apply the substitution Let us first make the form. Here we have 1 over 3. This can be written as 2 over 3x whole square minus 1 square root. Let us substitute t as 2 over 3x. So what is dt over dx? That is 2 over 3. Then what is our dx? Dx is 3 over 2 dt. So we have our integration as 1 over 3, dx is 3 over 2 dt. Here we have t square minus 1 square root. You can take 3 over 2 outside. This is just a constant. So our integration is just dt over t square minus 1. Integration of x square minus 1 square root is hyperbolic cosine inverse. So this is hyperbolic cosine inverse t. Our variable is t here. So here we have 1 over 2 hyperbolic cosine inverse t plus arbitrary constant c. Let's put the value of t. What is our t? We have taken t as 2 over 3x. After putting the value of t, we have 1 over 2 hyperbolic cosine inverse 2 over 3x, as t is 2 over 3x. If you want, you can convert this to its logarithmic form of hyperbolic cosine inverse, or you can leave it here also. This is our answer. In this way, you can solve the derivatives or integrations where you have inverse hyperbolic functions. And if you have any question, you can comment in comment section. Thank you.